and the radius. However, unsurprisingly, this is not a brilliant solution. Firstly, resulting the circle has large gaps where the slope approaches the vertical. See in this diagram, you can see there are large gaps between the circle as the slope is proceeding in vertical direction. So, secondly, the calculations are not very efficient because the square operations are lots of square operation, that is multiply operations are here. Then there are square root operations which are very hard to avoid. We need a more efficient, more accurate solution which was developed by Bressams, that is midpoint algorithm that we have already repeated. The midpoint circle algorithm was developed by Jack Bressams, who we heard about earlier. Bressams' patent for the algorithm can be viewed. Similarly, to the case with the line drawing algorithm, there is an incremental algorithm for drawing the circles, which is midpoint circle algorithm that we have already done. In the midpoint circle algorithm, we use 8-way symmetry. So, only ever calculate the points for the top right eighth of the circle and then use the symmetry to get the rest of the points. Mean you have to calculate the points, pixel locations on the first quadrant, that is 1/8 of the circle, and then same process is repeated for rest of the quadrants for the whole circle. Assume we have taken the points xk and yk, that is x coordinates and y coordinates, which is the current pixel. This is the pixel location which is the xk and yk having x coordinates and y coordinates. The next point is a choice between xk plus 1 yk and xk plus 1 yk minus 1, means the pixel will be lying above the symmetry or below the symmetry. If the pixel is lying above the symmetry, the value of x coordinates is xk plus 1 and the y coordinates is yk. And if it is lying below the symmetry, the value of x is xk plus 1 and y is equal to yk minus 1. So, we would like to choose the point that is nearest to the actual circle. So, how to make a choice? Then, so the method midpoint technique is used to make a choice for the points which are lying closer to the symmetry. Let us read the equation of the circle, which is x square plus y square minus r square, that is function of x and y. Then the function of x and y is less than 0 if x and y is inside the circle boundary, and it will be equal to 0 if x and y is on the boundary of the circle, and if the x and y is outside the circle boundary, then the value of fxy will be greater than 0. There are 3 values corresponding to functions of x and y. If the value is 0, this is the pixel which is on the circle boundary. If the value is less than 0, then the pixel is lying below the boundary. If the value is greater than 0, then the value is lying outside the boundary. By evaluating this function at the midpoint between the candidate pixels, we can make our decision to choose the pixels which are closer to the circle boundary. So, assuming that we have just plotted the pixel at xk, yk, we need to choose between xk plus 1 yk and the coordinate xk plus 1 yk minus 1. Our decision variable can be defined as pk is equal to f of xk plus 1 yk minus 0.5 and which is equal to xk plus 1 square yk minus 0.y square and minus r square. This is the decision variable pk which decides whether the pixel will be lying closer to the boundary or away from the boundary. And if it is closer to the boundary, then decision variable will choose that pixel. If the value of pk is less than 0, then the midpoint is inside the circle and the pixel is closer to the circle. Otherwise, midpoint is outside and the pixel yk minus 1 is closer to the circle. To ensure that the things are as efficient as possible, we can do all is to find out the calculations incrementally. Firstly, consider the value of decision variable, that is pk plus 1, which will be f of xk plus 1 and yk plus 1 minus 0.5, means you are to find the value of x coordinates and y coordinates incrementally on the x and y axis. It will be equal to x, this is the value of x square, plus this is the value of y square minus r square. Then pk plus 1 will be pk plus 2 xk plus 1 plus y square k plus 1 minus y square k minus yk plus 1 minus yk plus 1. So, yk plus 1 is either yk or yk minus 1 depending upon the sign of the pk. The first decision variable is as given. P naught, the value of p at point 0 is equal to f of 1 minus r 1 comma r minus half, that is equal to 1 plus r minus 1 by 2 square minus r square. 1 is the value of x coordinate, r minus half is the value of y coordinate. Putting the value in this equation, you find p naught is equal to 5 by 4 minus r. This is the value of decision variable at point 1 and r minus 1 by 2. So, if pk is less than 0, then the next decision variable is found as this, and if pk is greater than, then the decision variable will be pk plus 1, that is pk plus 2xk plus 1 and pk plus 1 is equal to pk plus 2xk plus 1 minus 2yk plus 1. This is the equation which is found by putting the values of x and y coordinates in pk plus 1 decision variable. The example of midpoint circle algorithm is as to see that the midpoint circle algorithm in action. Let us use it to draw a circle having center 0 0 and a radius 10. This is the example showing the circle which is drawn by having center which is 0 0, that is origin, having x coordinate and y coordinates as 0 and the value of radius r which is equal to 10. So, corresponds to the value of k. You can calculate the value of pk, that is decision variable, incremental value of x coordinates and y coordinates, and 2 into xk plus 1 and 2 into yk plus 1. To find, you can based upon all the calculations, you can find the value of these equations. Another method, another example of midpoint circle algorithm having a radius 15 will be as following. These are the location of the pixels which are drawn on the basis of decision parameters, that is pk. So, these are the two different examples having the radius 10, having the radius 15 and the corresponding values of the pixel drawn on the symmetry of the, that is boundary of the circle. So, the summary of midpoint circle algorithm, what we gone through is the key insight. The midpoint circle algorithm is it uses 8-way symmetry. It can be used to reduce the work in drawing a circle. When we use 8-way symmetry method to draw the circle, a lots of work can be reduced. Then moving in unit steps along x-axis at each point along the circle's boundary, we need to choose between the two possible y coordinates. The value of x coordinates will remain same. We have to choose the values between possible y coordinates, when the value of y can range from yk to yk minus 1. So, extension of line drawing algorithm, this is the extension of line drawing algorithm and it is test based on midpoint position. It is a test of drawing the circle based upon the midpoint position, that is the middle position of the pixel on the boundary of the circle. So, the position is checked using the function sine of x square plus y square minus r square. So, with the two steps we only use the additions. So, this is the summary of the midpoint circle algorithm, which is used to find the location of the pixels on the boundary of the circles, and this is the best efficient technique which is used these days to draw the circles. Thank you.